Hello everyone, welcome to AI Anytime channel. In today's video, we are going to work on a very interesting project. We are going to create a Streamlit application for personal carbon calculation. So we are going to create an app that will calculate the carbon footprint based on various factors. Okay. It's going to be a simple app, but very useful in terms of calculating the carbon emissions in personal capacity. So for example, if I have to calculate my carbon emissions, for example, on daily, monthly or yearly basis, how can I do that? How can I achieve, this task, okay, of calculating carbon footprint? How can we consider different scopes? So when I will explain scopes in detail, when I'm going to show you, the entire process of calculating the carbon emissions, both for businesses and also for individuals, okay. So let's jump in. So what I will do, I already have a folder called personal carbon calculator, and in this you can see I have a requirement file. Okay, so it's going to be a Python app, in using Streamlit. So Streamlit is a web framework. So let me just open my VS Code, and we only need one requirement, Streamlit, because calculating carbon footprint is not that complex from the technical standpoint, but it's complex from the domain standpoint. Okay, you should have domain knowledge to of something in sustainability, what are the different scopes, what are the organizations and the standards, recommendation and best practices. How do we calculate carbon emissions? These are more domain specific tasks rather than more technical tasks. So we only need Python to come up with a logic that will consider all these emission factors that I will explain later what I mean by emission factor, and we have to come up with a logic to build a simple app, okay, with help of some domain experts that they have already shared their details, the formula that they have published on the internet, and I have taken this how should I put it, the findings and insights to come up with this project. So in this project it will take various factors like transportation, the electricity and the wastage and the daily meal of food. So you only need Streamlit to just make this app. Okay, so let's build that. So we need app.py here. So I'm just going app.py, and here I will start writing code. So you can see I already have a venv. Now what does it mean? So I have a virtual environment where I've installed this requirement, Streamlit. If you are on Anaconda, you do not need to install it. You can just go in Anaconda and do conda install Streamlit or pip install Streamlit in your base environment. Okay, but if you want to create a separate environment, please go ahead and do that. So I already have created this environment. I will just activate that. So this is how we activate. So cd and your virtual environment folder name, then go inside scripts. If you are on Windows, if you are on Linux, you have to go inside bin, and then just /activate on PowerShell and cd dot, and here I am in my root directory, which is personal carbon calculator. This is our project name. Okay, personal carbon calculator. Let's start writing the code. So it will have 4 different factors. As I said, the first is transportation, electricity consumption and your wastages, and also the last one is basically the food. Okay, so how many meals the end user kind of consumes in a day. Okay, so that's what we are going to do. We are going to take all this input from the end user via our Streamlit application, and then we'll have our Python code doing the backend logic. Okay, so that's how we're going to execute. So let me just import the Streamlit. So I'm just going to say, okay, import Streamlit as st. Okay, and now let's give a title. So st.title, this is my title, and I'll say personal carbon calculator. Personal carbon calculator, and let's call this app. This is my title name, st.title. And how do we run a Streamlit application? It's pretty much straightforward. Streamlit run and your file name, which is app.py in my case. So let me just do app.py, which is a typo there. I'll just make it app.py. Okay, and now it will open the tab in a new browser, in a new tab. It will open your app, and you can see we have a new app called app Streamlit, and in this we can see personal carbon calculator app. Okay, so this is what we have to do. So if I explain, okay, that what are the fundamental things required to calculate carbon footprint. So there are some basic knowledge that you should have about the different scope. So we have scope 1, 2 and 3. When we are going to calculate carbon emissions, we have something called greenhouse gas protocol, GHG protocols, okay, which has some standard recommendations and best practices. Okay, now scope 1, scope 2, scope 3, and then upstream and downstream, how down you can go in the hierarchy, how up you can go in the hierarchy. Mainly when I'm talking about food, for example, I'm consuming some food after this video, for example, that's very difficult for an organization or also an individual to kind of track those things, right? Those things comes in scope 3 emissions. Okay, when we talk about purchases, electricity, etc., that can come in scope 2. So you have your IT solutions, you have your projects running on somewhere on virtual machine, somewhere on cloud, that might come in scope 2. So you should have all this knowledge. Okay, at least you can read this. I can share those links in the description, but today I will not go that much in detail on the scopes. We'll have just 4 factors as we mentioned. So let's define those 4 factors. So I'm just going to call it emission factors. Let me just define on top, okay, because we are not going to change this, at least in this video. So that's going to be emission factors, and let me just define these emission factors, and these are nothing. So let's have country wise. So I'm just going to consider India for for this video in this tutorial, but you can do it for the same for any other country. For example, if you want to calculate in the United States, the reason being because every country has their own carbon emission factor. Okay, so India has its own carbon emission factor, United States has its own carbon emission factor. So if you are going to extend this app for other countries as well, you have to take care of that. So I'm just going to do it for India, and I'm just going to create a dictionary here. So in India, and let's have our first factor, which is going to be transportation. So let me just write it out, transportation, and the carbon emission, the emission factor value for that. So let me just write it for, it is 0.14 in India. I will give you the link that where I have taken all this value. Okay, all the sources will be in the description. Okay, transportation, which is 0.14. Now what do you mean by this 0.14 value, guys? Okay, this is nothing but, let me just comment it out as well, kg of CO2. So let me just write it like this, kg of CO2 per kilometer. Okay, so the emission factor for transportation in India is 0.14 kg CO2 per kilometer. That's for 1 kilometer, that much of carbon has been emitted. Okay, that's the emission factor, 0.14. Now this is for basically for transportation. Now if I go next, the next, let's have it electricity. So for electricity, it's 0.82 to 0.85. I'll have 0.82 as the value, and this again, let's document this, a kind of a comment. So kg CO2 per kilowatt hour, which is a standard unit of electricity, kilowatt hour. Okay, this is done, electricity. Now the next thing is that diet. Let's keep it diet. For example, in diet we'll have the value is 1.25. so we have transportation, electricity, diet, and this is this is kg CO2 again per meal. Okay, so we are not going to do it per kg because we do not know that what's the how many kgs a person can eat, right? We do not need that. So this is an approximate value that has been calculated from that value. So if you ask me what is that value of kg CO2 per kg of food, and these are not that, we are not going that downstream here, guys. Okay, if the person is having veg meal or having a non-veg meal, because again, if you want to calculate that deep, if you want to go that deep to calculate this, yeah, you are basically increasing your boundaries there. Okay, so you have to define your boundaries, you have to know your scope. So we're just keeping it simple, but if you know that okay, X amount of veg and Y amount of non-veg has been consumed on daily basis, again you can add that as well. So 2.5 kg CO2 per kg. Okay, so this is on diet part of it. Okay, so we have taken per meal 1.25. Okay, so if a person consumes 3 meal, for example, in a day, we'll see that when we are taking the user input. So we have diet now. So then now next thing, the last thing is nothing but the waste. So we have waste, right? So waste, and this is nothing but 0.12. Again, let me just comment it out, kg CO2 per kg. okay, per waste. This can be municipal waste that we kind of in our household items, etc., that we have, right? The wastage. So this is the emission factor that we have defined. So these are the four factors that we are going to consider in this tutorial video, and we are going to calculate the carbon emission based on these factors. Okay, now this is done. Now if you see on this layout, as always, if you have seen my previous videos where I have created Streamlit application, I do not like this container or container fluid where your app is in center. I want to utilize the complete width of this layout. So let's do that as well. How do we do that, guys? So pretty much straightforward. ht.setPageConfig. We are going to use this method of Streamlit. Set page config. Just pass your layout, and layout equals wide because I need a wide layout. Let's just save it. And now when I run this rerun, and you can see now it's utilizing the entire layout here, guys. Okay, so personal carbon calculator app. Now in set page config, what you can also do, you can also set a page title, and you can also set an icon there if you want to use some emojis. So personal carbon calculator in this case. Okay, carbon calculator in this app. If you see, click on rerun. Now you can see in the tab, you can see it has been changed from Streamlit to personal carbon calculator. You can also use the emoji there if you want. If you fancy using emoji, please do that. Now we are set with set page config. We are set with the titles. Let's have some user inputs, guys. So what I'm going to do now, let's also comment it out. So user inputs. So we can take this value from the end user. And in this user input, let's first write ht.subheader, for example. And in this subheader, let's give an option if you want to extend this. If you're watching from any other countries, you can also build it for your country. So I'm just going to give you an option where you can add your country and extend this code further. So in your country, I'll just write like this: ht.subheader your country, and then country equals, this should not be cap, let's keep it small, the variable country equals ht.selectBox. So ht.selectBox, and in this I'm just going to have, for example, select. So let's have this select, and then we have, I'm creating a list here, and I'm just going to write India. But if you want to extend it for the United States, the any European countries, or UK, or any other Asian country, you can add that as well here. Okay, and you can extend it for. So country, and let's see if we are getting any changes here. Click on rerun. Now you can see your country. We have an option to select. You can add more countries here. Okay, this is done. So country is done. Let me also open, for example, globe emoji or something. Globe emoji GitHub or something. Okay. Now let's also use some emojis, guys. So I'm just come over here. I don't know. Let me search Control F if I can get globe emoji. Okay. Let's use this emoji here. Okay, I'm just going to copy this emoji, and in your country I'll put it over here. We'll Control S. Now come back and see if we're able to see any emojis. Then I can see we have an emoji. Personal carbon calculator app. So can we do it for calculator as well? Do we have any emojis for calculator? And we do not have anything for calculator, I seems. So calculation, nothing. Let me just see for add. So we have for add. Okay, we'll do that later on. So for now, we have our country here, and the next thing that we need, let's divide this in multiple columns, because we have now the full width, so we can utilize this in multiple columns as well. So I'm just going to divide this. So how do we do that? So after country, what I'm going to do, column 1, column 2, and I'm going to use ht.columns, and ht.columns, let's have 2 to give it equal weightage. I need 2 columns. And now with column 1, this is going to be my column 1. I'm just going to write ht.subheader, and in this daily compute distance, for example, daily compute distance, that is going to be in kilometer. Okay, this looks good. Now let's have a slider for this. okay, so the user can select it. So distance, and I'm going to use, it's a variable, we're going to store the value, so ht.slider, and in this I'm going to do, okay, this is going to be our distance. This looks good. So distance, and it should have a minimum value, it is again 0, and it should have a maximum value, which is again 100. And let's have a key, so do not get Streamlit error later on, because we are going to define, we also need multiple columns, and we will have more sliders, so it should not get confused which slider to use, right? So it start throwing you errors. So let's assign the key to each slider, or each input that we are going to have through slider. So key, and for this key will be distance input. So let's call this distance underscore input, and let's see if we are getting any changes on the UI, guys. So I'm just going to make a rerun here, and you can now see we have daily compute distance in kilometer. Okay, for this I think I can find some emojis. So let me do car. So I'm just doing car here. Okay, we got an emoji for this. Let's use this emoji over here. It looks nice. I'm just gonna paste it over here. Daily commute, and come here on this rerun, and you can see now we got an emoji here. So similarly, now we have daily compute distance in kilometer. Now what we have to do next, guys, we have to do it similarly for others as well. So we have our transportation done here for user input. So let's write for the next one. So the next one is nothing but, let's have one more subheader. I'm just going to copy this, guys. So ht.subheader to just save some time, and paste it over here. So now we'll not have daily compute. Let's call this monthly, for example, monthly electricity consumption, and that should not be in kilometer, it should be in kilowatt hour. So let me just write like this, and this should not be distance input. Now this goes electricity input, and this should not be distance, this should be electricity. So let's call this electricity, and this should be, let's call this 1000 to, this is done, 100, 1000, electricity, monthly electricity. Let's have some do we have bulb or something? Okay, we do have, so let's keep this as an emoji here. Okay, monthly, let's come back on the Streamlit app. Let's do a rerun, and now you can see we have our monthly electricity consumption. So now this done with the column 1. So column 1 we have our two factors, which is daily compute instance and monthly electricity consumption. Now similarly we are going to do for other columns. So let's go to column 2 now. So I'm going to do with column 2. And with column 2 again, let me just copy this to save some time here. I'm just going to do copy and come here and paste. So just pasting it over here. We don't need daily compute distance. Let's call this is going to be our waste. So waste generated per week. This should be in kg. So let's write that in kg. This should not be distance input. Now let's change this to something called waste input, and in distance this will again go back to waste. So let's make some changes here in waste. We have this 100 looks nice. Okay, and then we have monthly electricity. Let me remove this monthly to something called number of meals per day. So this will be number of meals per day. This looks good, and this should not be electricity. Let's make this meals, and this should be meals input now. So we have meals input. So ht.subheader number of meals per day. Let's use some kind of emojis if we can use. Okay, so waste, I don't know if we have emojis for waste. Okay, we have a waste emojis. Okay, this looks good. So let me put it over here on waste, and let's have something for food here, guys. So food, many for food we have. Okay, so for what should we have for food? Maybe we can keep this. Okay, So meals and waste, and then we do not have 1000 here, let's have only do not have slider here because we do not need slider for meals, because let's have a number input, because we do not have multiple, like 100 of meals in a day. We have around maximum 6-7 meals. So meals, and it should start with 0 and key as meals input. That should be waste input 0 100. This looks good. So now if I come back over here and I just do a rerun, now you can see we have our user input option. So daily compute distance, if you click this, it kind of, you can use it, you can see it's a slider, you can slide, and you can see it's sliding. Let me just make it 0 for now. Okay, let me just make this 0. And then we have waste, again a slider, and for this we have number input. You can increase your number of meals or decrease it. So let's keep it 0 now. So we have now an option to have 4 factors that we discussed in the beginning of the video, of the transportation, electricity, waste, and number of meals. I can find a typo there. It's multiple A here generated. Now this looks nice. Now let's come back over here and let's write the rest of the code. So let me normalize the input. It's very important to normalize, because we have different units here, days, week, month, and different kilowatt or kilometer, for example. Let me normalize this input. So let me just write normalize inputs. And now, so first thing is, if distance greater than 0, okay, this looks nice. So if distance greater than 0, you have distance equal distance multiplied by 365, because we are going to convert daily distance to yearly. So convert, and these are all average value, guys, okay, because we do not have data now. So we are just going to create something here. If you have data coming from your wearables devices, you can take this data from wearables device or any other data sources. You can take your food items from, if you are in India, you have this Zomato, Swiggy, multiple apps where we order our food for, or you have any bills, for example, you have your electricity unit bills. You can use all this data. You can use computer vision, OpenCV, for example, to perform OCR and get all this data and get this value that changes dynamically. Right now these values are not changing dynamically, but if you are interested to build a tool, if you want to extend this further, I'll be more than happy to collaborate with you as well, okay, because we have done this earlier where we have taken dynamic data to build carbon calculators. Okay, now convert distance to daily distance. So convert daily distance, so convert daily distance to yearly here. So I'm just going to make this yearly, and this looks nice. So same will go for if electricity. Just copy paste here, guys, quickly. So let me just copy paste. So I'm just going to paste it over here. I'm just going to paste again for, and one more. So if distance, this will change. So I'm just going to make change to here. If electricity greater than 0, then electricity, and let me just make this change, electricity into 365. This should not be 365, this should be 12 now, because we are taking monthly electricity consumption, if you can see it over here. So it should be 12, and this should not be distance. So let me just do an alt over here, so I can, sorry, excuse me, let me just do again an alt. And now if I make the changes for meals, so I'm gonna make the changes for meals, and if meals greater than this 365 is okay, because we have number of meals per day. And let me just do an alt over here again, so alt, and make the changes all together to waste. And this looks nice. So waste into 52, because we have weeks, so let's have 52 here, because in a year we have average of 52 weeks, right? So now we have normalized our inputs. The next thing that we are going to do is calculate the carbon emissions. So let me just write calculate carbon emissions, and now let's define the variable. So I'm writing transportation. Let me just, it's taken caps, so let me just make it small here, transportation emissions. Okay, we are going to calculate this category wise, and then we are going to sum it all together. So transportation emissions, let's have our emission factors, country. So our country, and sorry, I have written county here, it's going to be country. So country, and in country we have transportation. So let's have this transportation because we are doing it for transportation. And just what we're gonna do here is distance, which has our variable, which store the value here from the end user. Now this is for transportation, it will be the same for rest of it. So let me just write it over here quickly. And this should not be transportation emissions, so let me just do alt again here, and here I will just write transportation, so it will be electricity, but this will be caps, so let me write electricity caps here. And country, this should not be distance, this will be again electricity, I left that. And here, so let me just do alt, so this would be diet, so let me just make it diet here, so diet, okay, and this would be caps, excuse me, I think I selected there in a wrong pattern, so that will be your diet and that will be your meals. So meals is our variable where we have stored this, so meals. And in this transportation emissions, let's write it waste emissions, so waste, and this will be again your waste here, so let me just write it waste, and this again goes waste, so this will be waste again. So we have now distance, electricity, meals and waste. So we have transportation, electricity, diet and waste, and then we have transportation, electricity, diet. This looks nice. I think we are done with this calculation also. So now we are going to do convert emissions. So let me just write convert emissions. Maybe we can convert emissions to tons of CO2, which is the standard unit for calculating carbon emissions, to tons, and also let's round this up. So we're gonna round it to 2 decimal point. So round off to to 2 decimal places or something. Okay, I'm just writing it over here. So we're just gonna convert these emissions to tons and round off to decimal places. So let's call this total emissions. So what happened? I'm using tab 9 guys, so just kind of auto suggest your code. So total emissions, and in this total emissions, let's have a round first. So let me just round, and in this let's have transportation emissions plus waste emissions. Let's have in the same order as well. So electricity emissions plus we have diet emissions, and then we have waste emissions. That's it. And then let's round it up to 2. So 2. Now we have total emissions here. Okay, and this. The next thing that we are going to do here, guys, so convert emissions to transportation emissions, but this is your total emissions. Okay, but we haven't done the tons converted to tons CO2, right? So I think I missed that. So let me just add it over here. So in that case, let's have the same thing here. So I'm just going to copy here. So transportation emissions is nothing, but this will be again round off this transportation emission that we have in the above place here, transportation emissions, and that will be divided by 1000 to have in the tons CO2. Okay, so we have to divide that by 1000 because we need in tons CO2, we don't need in kg CO2 now. So transportation emissions by 1000, and then it goes to the value of 2 because we have to round it off again. So let me just copy that and paste it over here, paste it over here, paste it over here. And from transportation emissions, let me just also do an alt, and in transportation we'll have electricity. So let me write electricity, and here in this case what I will have diet emissions. So diet emissions, and here what I will have alt, and let's make this waste emissions. So we have waste emissions, diet emissions, everything rounded off, and now we have already calculated transportation emissions, total emissions. So next, now what we are gonna do, let's have a button, guys. So if st.button and in this I'll write calculate, for example, CO2 emissions or something like this. Okay, this will not be equals, and now we'll write our code. So the first thing is display result. So I'm going to write display result, and in this st.header, let's have a header and just call it result. So results. So this is your st.header where we are calculating the results. And now let's have two more columns again to show the results. So st.columns, very quickly, st.columns, let me write 2 here, and now with column 3. So with the column 3, and so now we're gonna write so st.subheader, and here we're gonna write carbon emission by categories in the first one. So carbon emissions by categories, carbon emissions by categories. This is my subheader, and now here I'm going to write the result. So st.info, the status message. Okay, the first thing, so let me write F, and we'll first write for transportation here. So transportation, and this will be nothing but the transportation emission. Yes, transportation emissions, tons of tons CO2, okay, per year or something. Okay, something like this. Okay, so this is, let me just copy this, it will be the same for all. So let me just write here, paste, paste. So now it should not be transportation, so let's call this electricity here, electricity, and this will not be transportation emission, this will again be electricity emission for this one. So electricity emissions, and this will be diet. So let me just write diet here, this will be your diet emissions, tons CO2 per year, and this will not be transportation, this will be a waste here. So this will be waste emissions. Okay, let me just write it off over here, waste. Okay, now let's have the emojis, guys. Where are our emojis? So first is this one, daily compute distance. Okay, so compute distance, let me put it over here, and it looks nice, on the Streamlit, supported by Markdown. This is a very powerful framework, guys, Streamlit. Okay, so for Streamlit, for electricity, this looks nice. Transportation, I think there's gap. Okay, let's have something like this. Let me do a Control Z. Okay, so electricity, and for diet, what do we have for diet? I think we have this number of meals thing. Okay, diet, and then we have a waste thingy here. So let me just copy it over here, and let me just paste, and this looks nice, guys. So we have waste. Let me just write for the last column as well, which is going to be our final result, the total emission. So let me just finish this as well. I'll just have this as well here. Okay, copy, let me paste it over here. I'm not going to call it carbon emission by category, this is total carbon footprint. So let me just write it, total carbon footprint, and here we'll have st.info. Let me just write, F, your total carbon footprint. Your total carbon footprint is, let's have this will not be transportation emissions, this should be your total emissions. So total emissions, tons CO2 per year, and here what I'm gonna do, I'm gonna use st.warning, and I'm gonna pass right now. Let me just write pass here, we'll change that later on. Now let's have the emoji, this globe emoji from here. Okay, I'm just gonna copy this globe emoji over, let me put it over here in this one. So now CO2 emissions per capita for India. Let me search one thing, guys. CO2 emissions per capita in India. CO2 emissions per capita in India. How much CO2 per capita? It was okay. Makes sense. It was 1.78 metric tons. Okay, it was 1.79 by 2021, if I'm not wrong. Yeah, you can see one per capita in metric tons. Let me just see. I just need one thing from it. I just need this. In India, CO2 emissions per capita. I need to put this in disclaimer in the warning as a disclaimer to people to understand. This is also an information, you can say, in a way that you can find it out if your value that we are calculating per individual is greater or lesser than per capita for India, which was 1.9 tons of CO2 per capita. And let's see that, guys. So now our code is ready now. Okay, so what I'm gonna do, okay, let's have this some here. Let's run this app, guys, now. So let me just go here. Okay, and here I will just do a rerun and I will run the code. It says name electricity is not defined. So if electricity greater than 0, it says it's not defined. So let's see 42. Let me just see that. Okay, okay, I got that. So we haven't changed this variable, we just copy it. So that will be electricity. This will be your waste, sorry. So in this case this goes waste, and this goes your meals, which is the last one. So let me write meals, and now let me just do the rerun. And now you can see once we click on calculate CO2 emissions, it will calculate. So let me just have daily compute distance, okay, in kilometer. So if you talk about a person like me who kind of daily compute distance, I think daily compute, it should not be compute, it should be commute. I don't know why I wrote compute there. Okay, let me just make these changes here, guys. Daily commute distance, okay. I'll just do a rerun here. So let me see daily commute distance in kilometer, waste generated per week, monthly electricity consumption, and number of meals. So I'll just make this 4 here, guys. Okay, so number of meals per day, electricity consumption. Okay, so let me just write monthly electricity consumption. Okay, let me just keep it here as okay, around 5 kilowatt hour monthly electricity consumption. Then daily commute, I think, okay, I'll make this around 20 kilometers, okay, on daily commute. And waste around 5 kgs, for example. Okay, so let me just keep 7 kgs, for example. Now this is the value that I have, right? For example, I'm living in India and I have my daily commute as 20 kilometers. I'm going to for study or for office or for whatever work. Then I have monthly electricity consumption. And then this is 5, for example, 5 kilowatt hour. You can check it on internet per capita electricity consumption in India on monthly basis. You will get some values there. I think it's 2.5 to 5 kilowatt hours. And then we have waste generated per week. This can be a municipality waste, that can be your any other waste as well, related to any materials. So this is, for example, 7 kgs, and then number of meals per day. So suppose, for example, if I have 4 meals per day, this goes a value there. Now if you click on calculate CO2 emissions, it would give me some values there. Here we go, guys. So we got our values. It looks so nice, isn't it? So we have our carbon emissions by categories. You can see transportation. So I have 1.05 tons CO2 per year. Then I have electricity, 0.06 tons CO2 per year. Diet, 1.82 tons CO2 per year. And waste, 0.04 tons CO2 per year. If you see, my total carbon footprint is 2.97 tons CO2 per year, which is greater than the per capita in India, which is 1.9 tons of CO2. So if I go with this speed, when it talks about the factors, if I make commute is, I'm having 20 kilometers, electricity, waste, and meals, its signs are not good, at least from my individual emission standpoint. But here is the catch, guys. Okay, let me just give you some info, and it's a discussion topic as well. Now suppose, for example, we have our monthly electricity consumption, right? I have shown here 5 kilowatt hour. Now just imagine if I am living in a home, okay, with my family, and if there are 5 members in my family, they all kind of utilize those electricity, the same electricity I am also consuming in a way, right? So there is also a distribution factor that we have to consider, but again, that's more domain specific, as I said in the beginning. that you also have to divide that by the number of members that you have. If you have the data there, okay, but we do not have the data, right? That's why we don't know. So we went with a simple approach, having 4 factors, come up with a logic, emission factors, come up with that formula and calculate the carbon emission there. Now the same goes from work. Suppose if you are doing work from office, so there are thousands of your friends are working in the office utilizing the same energy, then those gets distributed. So if you talk about those scope 2, scope 3 emissions, you have to be very, very careful in a way that your data, you have your data in your hand, how those has been categorized or divided per people or per employees or per member at your home. Okay, so and mainly the scope 3 emissions are very difficult to calculate. From an organizational standpoint, it's very, very difficult to kind of track scope 3 and calculate the carbon footprint there. But I'm not saying that it's not possible. It's completely possible. The way you kind of how should I put it, track your data. Okay, how do you collect the data and how do you define your boundaries and scope there. But anyway, that's not the concern, at least for this tutorial video. So what we did in this video, guys, if you see, we have a personal carbon calculator app in Streamlit. It looks very good, a simple UI. We have your country. Now you can go ahead and add your country, for example United States. If you are doing that, you have to change this here. Okay, in this, if you have to write it, so you have to make one more here after India, and you have to add United States, again the dictionary there for value assignment and all. Then we have 4 factors. You can increase the factors if you want. Okay, if you have any data about what kind of vehicles you drive, is it is the backend is or a diesel or a petrol or a CNG. If you have all this data value there, you can also calculate that. You can add it over here. You can go and search on internet to find out the emission factors. If you are in India, it's available. I can give you the link in the description. You can read about that. And then we calculated our carbon emissions by categories. You can see it over here. And then we have our total carbon footprint. And also we are comparing with the per capita, which is again not that the right approach to kind of measure this or kind of compare this value, I will say. But anyway, we kind of, now we have an app. So this is what I plan to do in this video, guys. I hope you like the video. Okay, this code will be available on my GitHub repository. Please go and find that. If you haven't subscribed the channel yet, please do subscribe the channel if you like the content I create. If you have any suggestions or feedback on this app, or if you have any doubts, I'll be more than happy to clarify that doubts, and I can also collaborate with you to extend this further. Okay, so please let me know your thoughts and feedback in the comment box, or you can also reach out to me through my social media channels there. That's all for today's video, guys. Thank you so much for watching. See you in the next one.